what does it mean to be a mathematician? Because, you know, often when I'm on a plane or at a party and people ask, what do I do? And you tell them that you're a mathematician, suddenly I get one or two answers. Can you imagine what answers I get?
You must be really smart.
You must be really smart. What's my response to that supposed to be? Yes, yes, I am. That's ridiculous. And if I say anything else, then suddenly, you know, it becomes a little bit awkward. So that is the first response I get. You want to guess what the other response is?
Why?
I hate math. I've never understood math. Yeah, so then I get to deal with that, right? So I think lots of the problem stems from people don't know what it means to do math or to be a mathematician. You know, if you ask people, what does it mean to be a scientist, right? What does it mean to be a biologist? What does it mean to be a chemist? What does it mean to be a physicist? They have answers for that, right? Biologists and chemists have labs. There's stuff going on, right? Maybe they have animals, or maybe they're, you know, mixing chemicals or something like that. Physicists, they've got great toys, right? Like particle accelerators and stuff like that. What does a mathematician do? You know, multiply 100-digit numbers? Like, no, that's not what I spend my time doing at all. So I want to talk a little bit about what it means to be a mathematician and sort of what, you know, in the theme of the symposium, what that superpower allows me to do. Okay? So what is mathematics research? And so by that I mean, what does it mean to discover or create? The choice of which word you use there could be a day-long conversation, okay? Do we discover math? Is it just there in the world waiting for us to find it? Or are we creating it out of nothing? Okay, depending upon which mathematician you talk to, you'll get a different answer to that, okay? But what do we do, right? What do we spend all day doing? So when I talk to people on planes and in other you know, areas like a grocery store or something, this is what they think I do, okay? They think that I write really nasty equations with lots of variables, and that's what it means. And so then, you know, they often will say something like, yeah, you know, that's not really what I'm looking to understand. So let's come back to these questions. They're good questions, and I feel like this comic does a good job of getting at this. I don't know if you can read it back in the back, but these are fields arranged by how pure, by how abstract they are. So over here toward me, we've got sociologists, and then psychologists, biologists, chemists, physics, and then way over there we've got mathematics, okay? The most pure, the most abstract of these disciplines. So I don't spend all day sitting around multiplying big, you know, large digits of numbers. I don't sit around integrating by parts or taking derivatives 5 times in a row. And this is not what mathematicians do. It's unfortunate that arithmetic has gotten all sort of tied up together with math and memorizing formulas. You know, something I like to tell my students is, you know, I don't put it in these words, but if someone held a gun to my head and said, what is Heron's formula for finding the area of a triangle? I have no idea, okay? I don't know. What's the law of cosines? I don't know, okay? But I could derive those things if I needed to because I have an understanding of what the mathematics is behind all of that. Okay, so if you were to ask a mathematician, what is it that we do? What does it mean to do math? One of the first things we'd say is to identify patterns. Mathematicians collect a bunch of data, they stare at the data, and then they make guesses or conjectures about what the universal truth is. Okay? So if we look at these rows here, you want to start shouting out to me what the sums of these are? 4, 8, 16, 25, 36. Okay, so what's the general pattern? What are we getting when we add up odd numbers? Squares, right? So we're getting squares. Now, one of the superpowers of being a mathematician and really understanding what is going on means that we have multiple ways of representing the same truth. So maybe your students or your children really don't like thinking about things this way, we can draw a picture of this result that proves exactly the same information. So what I can do is I can start listing the sum of odd numbers, and we see that when we do that, when we add them, that's where these squares are coming from. Okay, so 1 plus 3 is the purple plus the green. 1 plus 3 plus 5 is the purple plus the green plus the purple, and so on. Okay, so having multiple ways of representing the same pattern is a very useful thing. The other thing mathematicians do is we're curious. Okay, we ask questions. So once we know that something is true, we want to know, well, what else is true? Or why is that true? Or if I change the hypotheses of this statement, then is something new true? Is the same fact still true? So maybe we remember from our high school geometry classes the Pythagorean theorem. Okay, it says, gives us a relationship about the length of the sides of a triangle. And hopefully at some point in your life, someone drew for you the geometric reason why this is true. So the Pythagorean theorem is a theorem about areas. Those squares are literally about squares. Right? It says that the sum of the green and the blue square is, in fact, the yellow square. Right? So this is how we represent the Pythagorean theorem. So what would a mathematician do? A mathematician would say, great, that's great, but what if we replace the squares on the sides of those triangles by something else? What if I instead draw circles whose diameter is the length of the sides of triangles? Is it true that the area of the green circle plus the area of the blue circle is equal to the area of the yellow circle? Is that true? What if I replace the sides of my triangle by equilateral triangles? Is the result still true? What if I replace the sides by some other shape? Is it still true? This is what mathematicians do. Okay, so I like to, for my students, distinguish between exercises, which are what are in the back of the book, at the end of the chapter, they test drill, right? They test whatever skill it is that that chapter is covering. We call those exercises. But a problem is interesting, okay? A problem is something where we don't know what the answer is, and you know what? You have the tools to figure it out, but it's not going to be some recipe or some cookie cutter method that you learned in class. Okay, you actually need to synthesize material that you've learned from a bunch of different classes. Okay. What I'd like us to do today is I'd like you all to have the experience of being a mathematician. Okay, so those of you who are sitting in the back, if you would like to come up here and sit at this table. So I want a maximum of 4 people at a table. And what we're going to do is the following. We are going to talk about something in mathematics that is not known. Okay, so what does it mean to do math research? What does it mean to invent new mathematics? Isn't all mathematics known and in textbooks? No. Okay, there's lots that we don't know. So a graph is an object in mathematics. During the keynote talk today, Matthew said something about he was talking to a mathematician and she was so excited about these different animals and gadgets in mathematics. Right? This is one. A graph is this idea in mathematics that is extremely useful and has many applications to the real world. However, mathematicians are also just interested in graphs for their own sake. Okay? So when my students say, well, like, what am I going to use this for? I challenge them and I ask them, well, what do you use a painting for? What do you, when you go to the symphony, what do you use that for? What about nice parks outside? What's the usefulness of that? Why do we demand that mathematics has usefulness outside of just being beautiful and interesting in its own right? Okay, so graphs have that property. Thank you. Yeah, I'm glad. Graphs have this property that not only are they useful in the real world, but they're intrinsically beautiful and of interest to mathematicians. Okay, so if you can now turn it over to the other side. You might think that some of these graphs are more complicated than some of the other ones. It turns out that a ranking of how complex a graph is not something that mathematicians are in agreement upon. Okay? So if you talk to two different mathematicians, they might rank these differently and have reasons for doing so. So your task with your group is to decide how are you going to rank complexity of graphs. So I'll have you read this and I'll have you go through the steps. And then what your group is going to produce is a post-it note of your group's decision on how you are going to rank the complexity of graphs. And I'll walk around and answer any questions. And the beauty of this, there's no wrong answer. All answers are correct. Oh, sure.
Because all the nodes are the same, right? Each of those have the same nodes.
Same number.
Yeah.
That's what I was going to say. I think they're all exactly the same.
Same number of points or nodes.
So to me, they all have the same number of points.
For some reason, this one stands out as the most complex. I don't know why. It just seems because it's not
Lack of
there's nothing
connectivity.
linear. There's nothing.
Yeah,
There's no pattern.
Yeah, there's no
Exactly.
pattern.
Yeah.
I mean, these are
Again,
even though
some
it looks
different.
complex, but it's pretty
Okay, if I could just come up quickly before the end of our session. So thank you so much for the opportunity to be here with you today. I want to thank the Mind Research folks for the invitation to be here. And I hope, if anything, what you walk out of this room with is that it is not the case that there is always one right answer in mathematics. If I could dispel the general population of that myth, I would be very happy. And as many of you I talked about as I walked around to the tables, there is no best answer. If there were a best answer to this activity, mathematicians would have agreed upon what that answer was, and we would already know. Okay, so there's no best answer. All of your answers are equally as valid. And what we'll do is we'll post everyone's ideas out later this afternoon so that then you can see what other people were talking about. You can talk to other groups and so on. Okay? Enjoy the rest of the symposium, and I will see you later.